I'm going to talk about the C++ version now of the Polkadot RE. So this is called Kagome. Kagome in Japanese is like a reference to like a cross-thatched pattern. So it's kind of like the image of different things coming together, you know, multi-chain, interledger, different connectivities. It's what this is all about. My name is Makoto Takemiya. I don't look like a typical Japanese guy, but I moved I moved to Japan 11 years ago, and I became a citizen 4 years ago. So I changed my name and kind of did this. I'm kind of a researcher by background. I used to work in a neuroinformatics lab, and I kind of got into blockchain in 2013, and my life has never been the same since. So my company, I founded 3 years ago. We're about 60 people now. It's called Soramitsu, which means, it's a poetic term in Japanese mythology, meaning to see from the sky. And we are trying to create decentralized technologies that can help make the world a more efficient place. And so we created our own blockchain a few years ago called Hyperledger Iroha, which is a part of the Linux Foundation's Hyperledger project. It's all open source, Apache 2 license. And we're using it for some really cool projects, like working with the National Bank of Cambodia. We're working with the CSDs of, so the CSD for Moscow Exchange in Russia and KTD in Slovenia. And also works with some banks. But of course, we're also working on this project here, so Kagome, which is the C++ runtime environment. So our technology is kind of used for a lot of different things. So for example, this is one instance of an application we made called Bakong. This is actually the first live version of a central bank digital currency that was launched actually last month in Cambodia. We've been working with the Central Bank of Cambodia for the last 2 years. And we're also working on a really cool system called SORA. But today I'm going to focus mainly on Kagome. So this is the logo up there and some Japanese text. So this is really the framework for, as the previous speaker, Amin, said, it's really a framework that can be used to create, you know, many different components and can be the foundation for a decentralized web. And the main components that I'm going to focus on today are work on the networking layer, so libptp, and then consensus and WASM. So the stack we're using is C++ 17. It's a modern and very different language than you might have used if you had used C++ 10 or 20 years ago. So it's really kind of a very, I don't know, it's a very innovative language that has many millions of programmers around the world. So that's one of the reasons why C++ is a good target for also having a Polkadot runtime environment in. For networking, we've used a lot of things with a Boost ASIO library. We use Binarian as our WASM interpreter in C++. For dependency management for this project, we use hunter.sh, which is a great library in C++ if you're familiar with it. And of course, we support different major cryptography libraries, and we use LevelDB for storage. So this is the overall architecture, and what I'm going to do is kind of zoom into this real quick to kind of show you how this works. So this is actually a diagram of how the repository is laid out. So if you wanted to contribute to the project, this could be somewhat useful. So let's go into this a little bit. So everything kind of starts like down here in this extrinsic API, where if you want to create a transaction, you send it through this API, which can then go into a transaction pool. And then from the transaction pool, the current block, the current leader who's making the block proposal and the proposer can come here, and the proposer creates a block proposal from the transaction pool, which can then go over here. It comes into Babe, and then it goes into consensus through Babe, and then gets finalized up in the corner by Grandpa up there. And then you have the block storage, which is a tree structure, and you have the tree and then the key value map for the block. And you've got the networking with libptp over here. So you've got, as part of the consensus, connected to the networking services. And then over here, you've just got the runtime executor, which executes the different functions. So to step into this a little bit, so this is where if you want to create a transaction and then send it to the network, you would send it into this type of API. So this is where the transactions are submitted to the node and then goes into the transaction pool. And then once in the transaction pool, then the transactions can be used to be included into a future block. And this is done, of course, through the proposal mechanism. And this goes into Babe. So Babe, in our implementation in C++, this is still a work in progress, but I think the roadmap has it to be done next month. So Babe and Grandpa should be fully implemented next month, which I think is about on par with what Amin just said for the Go implementation. And then, of course, finalization comes using a PBFT style consensus for finalization in Grandpa. For the networking, we use libptp. So we actually implemented this in C++. So libptp is very highly supported by Protocol Labs, or created by them. So they did a great job helping us with our implementation. And libptp is aiming to be kind of a foundational modular system that can support many different types of transport protocols, so TCP, UDP, etc. And it can be really efficient for reusing different sockets, so multiplexing connections. And you can easily have encrypted channels like TLS protocol. So we use in our implementation Boost async IO, and this is based on different callbacks in the package. And all of the code in the libptp, in the future it will be its own repository, but right now it's under Kagome, underneath the core/libptp. And I'll put the link to the repository at the end as well, in case you want to check it out. To really be modular, the adapter pattern is being used for this. So there's many different ways this is done. But one really cool thing that libptp has is this kind of chaining of different things. So for example, if you want to use IPv4, you put IP4 / the IP address / the protocol's TCP, and then port number like 1337. So this is really human readable in many ways, and when it's actually used in code, and there's no time really to show a code example, but this is really very easy to read and to maintain. So the different users can implement these adapter interfaces to extend the PTP. So we have a transport adapter, a security adapter, and a muxer adapter for multiplexing. So the transport adapter, this kind of connects to remote peers, and it sets the handlers also for listening for incoming connections. And right now, we only have the TCP implementation, but in the future, I think UDP is the next protocol we want to implement. And then in theory, you could implement other protocols too. So again, the whole goal of libptp is to create these different modules that you can then use again and again in different applications. So the security adapter takes the raw connection and it turns into a secure one using the protocol that you're using. And this includes also doing handshake agreement with the remote peer. So one peer proposes the protocol that they want to use, and the other peer would either say the same protocol that they want to use, or they wouldn't return a proper response, in which case you would have to propose a new protocol. So you have this agreement. So for example, if you use like TLS version 1 and another node uses TLS 1.3, you could do this type of agreement to choose which version of TLS to use for the two nodes. Muxing is the multiplexing over the connections. So actually, libptp is really efficient for this. So instead of maintaining a pool of different connections between the same server, which you would have to do because there's different types of data that you need to share with different peers at different stages of the pipeline. So instead of opening multiple connections, you just have one connection that is then multiplexed using this protocol. And currently, we just have a Yamux implementation, but in the future, you could have other implementations, and we're working on this as well. And this is also open source, so feel free to contribute. WASM, as Amin said in the previous talk, it can be kind of tricky to find the right library to use. So we used a library called Binarian. So this is a set of WASM toolchains. It includes an interpreter and sufficiently maintained by the WebAssembly community. That's one of the advantages of using C++, I guess. So this is really, it aims to fulfill the the goals of WASM, which is to be as easy as possible to use, and then fast, and then effective. And so you can perform different optimizations using this library as well. So this has been really a great tool for us to use, and I recommend you to check it out as well. Our future plans is to release version 1 of this in September. And so this would have all the core components, which would be the extrinsic API, the transaction pool, Babe and Grandpa, and then also the Merkle tree as the data storage. And then we want to continue to do different things, like to make a light client that could connect to this, and then also build maybe some kind of wallet application, and even integrate with Hyperledger Iroha. So one of the cool things I think about Iroha is that it really focuses on mobile applications. So we have SDKs in different languages, and so if we could build a link to Polkadot RE as well, you could in theory move assets from one enterprise application to another, which would be really quite a cool thing to do. Our repository is on GitHub, so please feel free to check it out. We just have it right now under our company GitHub repo, Soramitsu/Kagome. And everything is Apache 2 licensed, so feel free to steal this code and improve it, and we hope that we can get some pull requests from different people. C++, especially C++ 17, is a very let's say, complex language, and there's a lot of nuances. But for people who really know the language, it's also a great opportunity to contribute to the community. And lots of people know C++, and at the end of the day, it's not magic. It's a programming language just like anything else. And so I encourage everyone to help us out with that. So I think that's kind of the overview that I want to present. This is still, of course, a work in progress, but libptp is mostly done, and consensus we should finish in September. So feel free to check out our repository, and if you have any questions, rather than do it now, I think I'll just yield back my time, and you can talk to me. I'll be around all week. So thanks, and have a great discussion.